This is the topic, Modern Physics, and the section called Particles of the Standard Model. Particles of the Standard Model is actually a single chart on your reference tables. And what I'd like to do is show you all of the information that is right on that chart, so you don't have to memorize anything. Now, I will let you know when I mention something that is not on the chart. I turn in your reference tables to the page that has energy level diagrams. The energy level diagrams at the top are hydrogen and mercury. On the lower left, you have a chart called Classification of Matter, which is covered in the next section. Here on the lower right, we have the chart called Particles of the Standard Model. And again, I don't want you to get anything wrong on the Regents exam because there is a lot of information right on the chart. You don't have to memorize anything to get some of these questions right. Now, on the chart, there are two major categories of particles. On the chart, we have quarks on top, leptons on the bottom. Again, quarks on top, leptons on the bottom. Now, why are these two kinds of particles the two major categories on this chart? It's because these two types of particles are at this time thought to be elementary particles, meaning that they cannot be broken down into any smaller particles. If you think of an atom, you know that an atom is not an elementary particle. It's not the smallest particle. Atoms are made out of smaller particles, protons, neutrons, and electrons. Now, even the proton, which we will see in the next section, is made out of smaller particles called quarks. So what we have here are elementary particles, particles that are not made out of smaller particles. Quarks and leptons are the smallest particles that we know at this time. Let's take a look at the 6 types of quarks, which are right on the chart now. All right, 6 types of quarks. Oh, and physicists gave these particles funny names on purpose. They like to have fun once in a while, too. So the names of the particles, now look, there are 6 boxes up on the top. 1, 2, 3, 4, 5, 6 boxes. And each box has a different type of quark. 1, 2, 3, 4, 5, 6. So what have we here? We have up quarks and charm quarks. We have the top quark, right? Up quarks, down quarks, charm quarks and strange quarks, top quarks and bottom quarks. Now, what about the symbol for each quark? Each quark is symbolized by the first letter of its name in lowercase. So, an up quark would be a lowercase u, a C for charm, and a T for top. D for a down quark, S for a strange quark, and B for a bottom quark. Also on the chart is the charge of each quark. All 3 on top have a charge of positive 2/3 E. Positive 2/3 E. All 3 quarks on the bottom have a charge of negative 1/3 E. Negative 1/3 E. Now that E we've seen before. That's the same E that's on the front page of the reference tables. Right there on the front page. The elementary charge. equal to 1.60 times 10 to the negative 19 coulombs. So this is really 2/3 of 1.60 times 10 to the negative 19 coulombs. Let's figure out now exactly how much the charge of these quarks are in coulombs. We'll do that math now. But you see that all this information is on the chart, and you can just look it up during the Regents exam in case they ask a question that's read directly from the reference tables. All right, so let's calculate the charge on an up quark, a charm quark, or a top quark. It would be positive 2/3 times E. That's positive 2/3 times, again, you go to the front page of your reference tables and copy E, 1.60 times 10 to the negative 19 coulombs. If they ask you for a charge in coulombs, right, there's your elementary charge there. Now, how should we do this math? There are two ways we could do it. We could say 2 divided by 3 and then multiply by 1.6 times 10 to the negative 19. Let's do that. All right, 2 divided by 3, 0.66666, times 1.6 second E negative 19. And what are we getting? We're getting 1.066666. So I'm going to round that to 1.07 times 10 to the negative 19 coulombs. That's the charge, all right, Q, the charge on an up quark, all right, a charm quark, or a top quark. That's the exact charge in coulombs. Now, there's another way you could do the math. You could say 2 times 1.6, all right, 2 times 1.6, second E negative 19, equals, I've got 3.2 times 10 to the negative 19. Now divide by 3, and you get the same answer, of course. All right, so two different ways that you could handle the math there. Let's try the charge on the other 3 quarks. The charge on a down quark, a strange quark, or a bottom quark. Remember that those quarks are negatively charged. So here we go. Negative 1/3 times E, negative 1/3 times 1.60 times 10 to the negative 19 coulombs. All right, let's say, we could say 1.6, all this divided by 3. We could do it that way. 1.6, second E, negative 19. All that divided by 3 is 5.333, that's repeating, times 10 to the negative 20 coulombs. That's the charge of either a down quark, a strange quark, or a bottom quark. Or you could say 1 divided by 3, do that first, equals 0.33333. Now multiply that times 1.6 second E negative 19. You get the same answer. All right, 2 different ways to approach the math. Not really a big deal there. All right. Now, let's talk a little bit about anti-quarks. We have quarks, and from this chart we can also figure out a lot about anti-quarks. Now, let me show you how this is done. It's not specifically shown on the reference table, but it's very easy to remember enough about anti-quarks to use this chart to tell you all about anti-quarks the same way it tells you all about quarks. All right, so let's take a look at anti-quarks now. And remember that quarks are made of matter. Quarks are matter. And anti-quarks are, you guessed it, antimatter. Antiquarks are antimatter. Every type of particle of matter has a corresponding particle made out of antimatter. Every type of particle made out of matter has a corresponding particle, antiparticle, made out of antimatter. So, for example, there are quarks and antiquarks. There are up quarks and up antiquarks. Let's look at the antiquarks now. And again, we can use the reference table as a guide to the antiquarks. All right, let's look at the note at the bottom of the page. On the chart that says particles of the standard model, down at the bottom it says note. All right, let's read that note right now. And it's similar to what I was just talking about. Note. All right, take a look at this. For each particle, comma, there is a corresponding antiparticle with a charge opposite that of its associated particle. All that's saying is that if the charge on an up quark is positive 2/3, that means the charge on an up antiquark would be negative 2/3. The particle and the antiparticle have a charge with the same magnitude, opposite sign. And while we're at it, the same mass. All right, so the particle and the antiparticle. It says here that the up quark has a charge of positive 2/3. Positive 2/3 E. Now, the anti-up quark would have the same magnitude, but opposite sign. So it would be negative 2/3. The mass of the up quark and the anti-quark, up anti-quark, would be the same mass. All right, now, let's look in much more detail at the anti-quarks and how this all makes sense. Again, this is spelled out right on the chart. You don't have to memorize this. It's on the bottom of the chart. Memorize the stuff that I wrote at the bottom here, what's not specifically on the chart. All right? All right. So let's take a look at the antiparticles. Let's take a look at their symbols and their charges. Let's start with the up antiquark. Now, it's correct to say up antiquark. It's not exactly correct to say anti-up quark. You always say anti-quark, so it's up anti-quark. How is it symbolized? You take the same U, put a line over to show we mean the antiparticle. the charge is the same magnitude, 2/3, but opposite sign. Or you could just say opposite charge. So the charge would be negative 2/3 e. The mass of the up quark and the anti-quark, the up anti-quark is the same. The mass would be the same. So if an up quark on this chart is U, plain old U, and positive 2/3, the up anti-quark is U with a line over it and negative 2/3. Let's look at another example. And let's look at a charm anti-quark. Charm anti-quark. The symbol for the charm quark is C, but if we mean the anti-quark, the charm anti-quark, put a line over it. That line means anti. So this is the charm anti-quark. And the charge would be negative 2/3 e, because the charm quark, according to the chart, is positive 2/3 e. So the charm anti-quark is the same magnitude, 2/3, but opposite sign or opposite charge. Let's do one more on the bottom. How about the down quark? All right. Let's do the down anti-quark. All right. According to the chart, the symbol for the down quark is D. But if we want the down anti-quark, we put a line over it. That line means anti-quark. Now, the down quark is negative 1/3 e. That means that the down anti-quark is positive 1/3 e. All right, so we can very simply figure out a lot of information about anti-quarks using the chart. Even though it's not specifically there, we know that an anti-quark has the same magnitude but opposite charge or sign as its quark, its corresponding quark, and the masses of the two particles would be the same. We don't often talk about the mass of a quark or an anti-quark, but the masses would be the same. All right. We've talked all about quarks. In the next section, we will be building other particles out of quarks and anti-quarks. For now, I want to talk about the other particles on this chart, the other elementary particles, the leptons. Let's talk about those now. There isn't a whole lot to say beyond what's on the chart. So here we go. Again, the leptons, like the quarks, are elementary particles, because at this time we do not believe that there are any smaller particles that they could be broken down into. Look at the bottom of the chart. Leptons. There are 6 of them listed. Leptons. All right, we've got our old friend, the electron. And again, there are boxes down here. There are 6 boxes, 1 box for each lepton. The lepton, the muon, and the tau particle. You might not have heard of these, all right, but they will ask questions about them on the Regents exam because they expect you to just look at the chart and answer the question based upon what you see on the chart. Now, the other particles are the neutrinos. Down at the bottom we have electron neutrino. And I think you can see where this is going. Each lepton has its own corresponding neutrino. The electron has the electron neutrino. The muon has the muon neutrino. And the tau particle has the tau neutrino. What are the symbols? Electron, muon. Muon is the Greek letter mu, the same as the coefficient of friction. the tau particle has a lowercase Greek tau, T. Now, the electron neutrino, all right, a kind of a fancy little V with an E for electron, a kind of a fancy little V with a mu, all right, and a kind of a fancy little V with a tau. All right, so those are the symbols for those particles. What about the charges? The electron, the muon, and the tau are all -1. The neutrinos, as their name states, neutral, are neutral. The charge is 0, 0, 0. All right? And that's about all that we have to say about the leptons. Keep in mind that our old friend the electron is the most common lepton. All right, so this topic here, this section of modern physics, was about quarks and leptons, which are found, what did I do with my reference table? Which are found on this reference table. And again, most of what you need to know you can read straight from the reference table. Keep in mind a few little things that I said about anti-quarks, which will also help you get more out of this reference table. I will see you in the next section.